Hello my dear student friends, welcome you all to this video lecture series of digital image processing. Right now, currently we are discussing about the morphological operation on image processing, right? In that we had a discussion about erosion and dilation, right? Okay, now everywhere we are going to have the discussion about erosion and dilation because each and every morphological operation involves erosion and dilation operations only. Okay, so all the algorithms are based on these two processes only, right? Okay, so we had a discussion about the erosion and dilation, you know that very well, right? So now we are going to discuss the new operations, that is nothing but opening and closing operation. Okay, so we are going to discuss now opening and closing operation on images. Okay, so again these are basic fundamentals again for going for the uh, more algorithms based on the morphological operations. Okay, so remember that now we are going to discuss the opening operation. Okay, so this opening operation will give us more smooth image. Okay, so how to get it and all this, that we are going to discuss in the further discussion. Okay, so opening operation is nothing but an operation. Okay, so A is my original image, O stands for, or this is nothing but the symbol for opening operation, that operation with structuring element B. Okay, so this opening operation consists of two steps. First is, so in first step we are going to erode that image. So A image will be eroded with structuring element B. Okay, let us say this is nothing but my C image. Okay, so we are going to perform the erosion operation on image A, and let us say that image is nothing but my C image, and the second operation is nothing but what? We are going to perform the dilation operation on this eroded image. Okay, so C dilated with structuring element B. So this is the second step. Okay, so remember that this is nothing but the equation of opening operation. This image, first image A is eroded with structural element B, and then that resultant image is dilated with the same structuring element B. Are you getting it? So these are the two fundamental steps involved into the opening operation. I hope the fundamental related to the opening operation is clear to you people. Now you know that what is erosion, what is dilation, right? So erosion is increasing black pixels and decreasing white pixels, right? Erosion consists of increasing black pixels and decreasing white pixels. Okay, and there are three cases. Okay, so if there is a perfect match, then only it is 1. If there is partial match, let us say partial match, then it is 0. If there is no match, then also 0, right? We had already talked about this. Okay, and what about dilation? A dilation consists of, in this case what we used to do, we used to increase white pixels and decrease black pixels, right? That means we are going to fill up the gaps, and over here we are going to disconnect or remove the gaps. Okay, in case of erosion we are going to remove the gaps, and in case of dilation we are going to fill up the gaps with the some white pixels. Okay, so it is also having three cases. Similarly, if the perfect match is there, then we are going to put it 1. If the partial match is also there, then also we are going to put it as 1. So that's why the number of white pixels are going to increase. Okay, and finally if there is no match, definitely we are going to write it as 0. So you please remember this. I hope you still remember. Okay, so in previous lecture we had a discussion about this. Okay, so let us perform the opening operation with the help of one example. Okay, let us discuss. the opening operation with the help of one example. Okay, so let us say this is my original image, for example. Okay, 0 0 1 0 1 1 0 0 1 1 1 0 0 0 1, and let us see this one all 1. Okay, wait a minute. So this is my A image, and let us say my structuring element B 1 0 1 1, for example, and let us say this is my origin. Okay, fine. So let us operate this with this. Okay, fine. So first we are going to erode that image. Okay, so we are going to perform the erosion operation, right? Okay, so let us perform the erosion operation. If the perfect match is there, then only it is going to become 1, else it is going to become 0. Okay, so is there any perfect match? So there is no perfect match, so therefore all the elements will, yes, over here only the perfect match will be there. Okay, so therefore this element will be only 1, rest of all elements will become zeros, right? And this boundary will as it is, okay, because there are no values after this, so this boundary will be there. Okay, and this also will be there, this boundary will be there. Okay, so finally let us write this. So if I am going to overlap this onto, let us say, this 0, what will happen? As there is no match, okay, so definitely it will become 0. So this is going to become 0. Let us overlap that structuring element on this 0 now. Let us say this is pixel. And is there any perfect match? No. So this is also going to become 0. What about this? So this is a mismatch. Okay, so these two elements, okay, only this element is not matching, so there is no perfect match, so therefore this also 0. What about this? This is also 0. We cannot perform operation over here because we don't have 0 padding and all these things, so it will as it is 1. Okay, so over here if I am going to overlap this on this pixel, then what is going to happen? As there is no perfect match, so this is going to become 0. On this as well it is becoming 0 0. What about this? This is also becoming 0. This is as it is, no change. Onto this it is having match. Okay, so perfect match is there, that's why it is going to have 1. This is also 0. This is also 0. This is also 0. This will as it is 1. Then 1 1 1 1 1, right? Okay, now onto this image, this is nothing but my A eroded with B image. Okay, so this is nothing but my A eroded with B image, right? Now on this image we are going to perform the dilation operation by using structuring element B. Now let us say this is nothing but my C image. Okay, now we are going to perform C dilated with B. Okay, so partial match or perfect match, if it is there, then we are going to write it as 1. So is there in partial or perfect match? No, so it is as it is 0. Over here, is there a partial or perfect match? No, so this is also 0 0 0 and 1. It will be as it is, no change. Is there any partial match? Yes, this match is going to happen, right? That means now if I am going to overlap this 1 onto this 0, then this partial match and this partial match is occurring, right? So that's why this is going to become 1, right? Let us operate or let us transfer this at this position. Is there any perfect or partial match? No, there is no perfect or partial match. if I'm going to overlap on this element, there is also no perfect match or partial match. If I'm going to transfer it at this position, there is also not. Okay, so this one is as it is. Okay, let us come to this point. There is a perfect match as well as yes. So over here, if I'm going to overlap the structuring element on this particular pixel, then there is a perfect match. So therefore 1. What about this? Over here it is a partial match. Okay, so therefore it is 1. Over here also there is a partial match, right? So therefore it is 1. Over here as well there is a partial match, so 1 1, and rest of others are 1 1. Okay, so this is nothing but the output of my opening operation. Okay, so this is nothing but providing me the smoothing operation if I'm going to perform the opening operation onto an image, original image, let us say A. Okay, so this is nothing but my final image. Okay, and that image is represented with this operation, A opening with B, and this is nothing but my final image. Okay, so let us check out what kind of images we can get after performing the opening operation into the slides. Okay, yes. Okay, so opening generally smooths the contour. Okay, so whatever the edges are there, that edges will be smoothened out. Okay, and it also removes the protrusions. Okay, fine. Let us check out the opening operation. So opening operation, that formula is over here. Okay, yes. So this is nothing but the formula of opening operation. Okay, let me, yes. I hope we had a discussion about this. Okay, so opening operation is nothing but A eroded with B, and then the eroded image will be dilated with B. That is the formula. Okay, this is the opening formula. Closing we are going to discuss in the further slides. So right now we are not going to discuss that. Okay, fine. So let us check out what will be the output of opening operation. Okay, so the contours, that means edges of your images, are going to get smoothened out. Okay, so sharp edges was there, right? And that edges have been now converted into a smooth edge. Okay, so these sharp images or sharp edges have been converted into a blunts. Okay, so sharp edges have been converted into a circular type of shape, semicircular type of shape. Okay, because the structuring element used over here is nothing but circular type of structuring element they have used. Okay, fine. So you can read the structuring element B rolling along the inner boundary of A. This is nothing but my image A, and it has been rolled at the boundary of your A image. Okay, and inside that particular A image, this structuring element have been translated, or it has been moved across that particular A image. Okay, so for example, let us say there is a triangle. Okay, so for example, let me discuss that. So this is my triangle as like that image. Okay, and my structuring element is like this. So whenever I am going to move that structuring element at this portion, so we cannot cover up this area. Okay, so this area is simply becoming 0. Okay, fine. And then because it is if it is not matching or perfectly matching. Okay, fine. So because of that, all the elements over here are going to become 0. Okay, because we are going to perform first erosion operation, right? So this area will be removed out. Okay, similarly, if I am going to roll out over here up to this portion, then all the, let us say, perfect matches are there. Okay, so let us say all the this structuring element and the values are there that are perfectly matching over here. Okay, for example, let us say all the elements over here are zeros. Okay, let us say all ones and here also 1. So for perfectly matching, if it is perfectly matching, definitely all the elements will be there, okay, across that line. But over here we cannot perform that operation, fine, and because of that there is no match, or we can say that the portion has been converted into black pixels. Okay, fine. That means that portion we haven't considered. Okay, right. Also we are going to move along this line as well. Then in that portion also, this area we are not going to consider for the our image. Okay, so I hope you still remember that in case of erosion the area is going to get reduced, right? In case of erosion, that area is going to reduce. In case of dilation, the area is going to get expanded, right? So like that, because of that, this area has been reduced, or it has been clipped out. Okay, it has been clipped out. Remember this. For example, this kind of structuring element we have discussion. Okay, we had a discussion about this kind of structuring element, and the let us say this is nothing but my image, and if I am going to roll over this, only the line was there, right? That line was present only, right, after performing the erosion operation. I hope you still remember it. Okay, let us discuss that again. Yes, okay, just check it out. So this is nothing but my output of eroded image, right? And once I am going to perform the operation like this, then the edges are going to get clipped off, right? So because of that, here also it is going to happen in a similar manner. Okay, so these areas are going to get clipped off, right? And only such kind of image you will be getting at the output of your image. No sharp edges. Okay, so it is going to smooth out your edges or boundaries, right? Okay, fine. Similarly over here also. Okay, now here we are going to discuss the closing operation. Okay, so let us discuss the closing operation. Now we'll discuss the closing operation. Okay, fine. So closing operation now. Now closing operation and opening operation are exactly reverse in manner. Okay, sorry, operation. I have to write operation. By mistake I have written opening. Okay, closing operation is exactly reverse operation as that of opening. So as the name itself indicating, they are opposite in meaning, right? So in case of closing, first we are going to perform the dilation operation. Okay, so A image will be dilated with structuring element B, and then let us say this is nothing but my C image. That C image we are going to perform a erosion operation with structuring same structuring element B, right? So I hope this is very exactly reverse operation, right? In case of opening operation, what we used to do, we used to first perform the erosion operation and then we used to go for the dilation operation. But in case of closing operation, what we used to do, we are going to first perform the dilation operation and then we are going to perform the erosion operation. So this is exactly reverse operation. Okay, so this equation is represented as closing is represented by a dot. A dot B is equals to A dilated with B and that dilated image is eroded with structuring element B. So this is the equation of closing operation. Is that fine? Great. So let us discuss the same figure. Let us take the same similar kind of example again. Let us say this is my A image. Okay. So 1 0 1 0 1 0. Let us say 1 1 1 0 0 1 1 0 1 0 1 1, and then 1 0 1 1 1 0. So this is my original image, and let us say structuring element as that of whatever we have used in a previous case. Okay, so this is the origin. Let us perform the first dilation operation. Okay, fine. So A dilated with B. What is dilation operation? Perfect or partial match. If it is the perfect or partial match, we are going to write it as 1. So for this, what is going to happen? It will be remaining as it is 1. For this 0, it is going to become 1. For this 1, again the partial match is there, so therefore it is also 1. What about this? There is no match, so that's why it is 0, right? For this, there is a partial match with this one, okay, and this one also. So therefore this is 1. The last element will not have any effect because we haven't performed any zero padding effect. Okay, fine. For this one now, partial match is there, so therefore 1. For this, partial match is there, so 1. This 1. What about this? There is no, yes, partial match is there, right? So 1. This 0, yes, there is a partial match, and then 0 1, sorry, not 0, 1, and this is also 1. Okay, for this there is a partial match, so 1. There is a partial match, 1. What about this? The partial match, perfect match is there, 1. Partial match, 1 as it is, and the last row is as it is. Is that fine? Okay, now let us perform the erosion operation onto this particular image. Okay, fine. So let us say this is nothing but my C image. Okay, so onto this C image, now let us perform the final image is nothing but C eroded with structuring element B is, if the perfect match is there, then only 1. So is there any perfect match? No. So therefore it is 0. Is there any perfect match? No. 0. Yes, there is a perfect match, so 1. What about this? There is also perfect match, so 1. Sorry, I forgot to take this 0. So first this will be a 0 because there is no perfect match. So 1 and 0. What about then this one? There is no perfect match, so 0. No perfect match, 0. No perfect match for this, 0. Here also no perfect match, so therefore 0 0 and lastly 1. Okay, similarly this, there is no perfect match, 0. Then also 0 0 0 0, and lastly as it is 1. Okay, yes, now finally last row it will be as it is, there is no change. So this is nothing but my operation, closing operation. Have you understood this? Okay, so let us check out what can be the changes into the image. Okay, so over here, so this area is only removed the sharp edges. Okay, so these sharp edges have not been removed into this closing operation. So that is the only change in case of closing operation. So every sharp edge will not be reduced. Okay, in this case. Okay, only this area is only those sharp edges have been removed. Okay, Yes, so complete closing we did, or clarity. Okay, fine. Let us take one more example so that you can understand it very well. So this is nothing but a morphological opening and closing operation performed on this particular image, and this is a structuring element. Okay, so A is yes, A is my image, okay, original image, and this is nothing but the structuring element, right? Okay, so whenever we are going to perform first opening operation, then this area is clipped out, right? So that means thinning operation has been performed. That means this image was there, and once I am going to perform the operation, this area and this area have been cutted out, right? Only this part will be there, right? And this part is also removed. Yes, so these edges have been removed. Okay, yes, erosion. Okay, and finally this is the dilated image. Okay, after performing erosion operation, we are going to perform the dilation operation, and in that dilation operation these edges have been made blunt, right? Yes, so wherever there is a sharp edges, that have been converted into the curved edges. Okay, so that is the operation we are going to use in case of image processing. Okay, opening and closing operations. Okay, fine. So duality and so duality means exactly reverse operations, complement and all these things. Okay, so duality means the complement of A closing with B is equals to complemented A image, okay, opening with structuring element B, okay, and opening of image A and structuring element B and its complement is equals to complement of original image and the closing operation with structuring element. It is nothing but the duality operation of, or duality relation between the opening and closing operation. Okay, great. Okay, the properties of opening and closing. Fine, we'll discuss this. The properties of opening is nothing but A opening B is a subset of that particular image A. Okay, so whenever we are going to perform the opening operation, so whatever the resulted image is nothing but the sub image of my original image. Okay, so if I am going to consider, let us say, A image, fine, and if I am going to perform the opening operation, then the sub part of that image is nothing but my opening operation performed image. Okay, so it consists of, it is a subset of particularly original image, right? Fine. And then if I am going to talk specifically related to the closing operation, so A is a subset of your origin the closing image. Okay, so your original image will be the subset of the closing operation performed image. Okay, are you getting the relation? The property of opening image or opening operation is what? The opening operated image is subset of original image, but in case of closing, in the property of closing operation is what? Your A image, that is original image, will be the subset of new closing operation performed image, right? So that is the meaning of this particular property. If C is a subset of D, then C closing with B is subset of D closed with B. Okay, So everywhere there is a dot. Okay, if C is subset of D, okay, so C image is there, and if it is subset of D, suppose this is D image, and for example it is nothing but a C image. If C is subset of D image, then operation performed on C image with a structuring element, that is nothing but the closing operation performed on C image with a structuring element B, it will be the subset of D image, D opening operation performed with the structuring element B, and this is the relation between that. Okay, fine. Now let me check this. I think this is somewhat confusing. Okay, it may be okay, I'll once again I will check it, and then we'll discuss this property, last property. Okay, fine. Okay, now let us discuss finally how we can use the closing and opening operations in order to get the contours of your fingerprints. Okay, so over here this is nothing but my original image. Okay, so original image of a fingerprint. Okay, and this is the structuring element over here. Fine. Then this image is nothing but opening operation performed image. Okay, over here the number of these white pixels have been reduced, right? So remember that whenever we are going to perform the opening operation, the black pixels are going to increase. Okay, so it is going to increase the black pixels, reduce the white pixels, because we are going to first perform what? Erosion. Okay, so therefore once I am going to perform the erosion operation, so definitely black pixels are going to increase, right? So you just check it out. Once I am going to perform the erosion operation, definitely the black pixels are going to increase and white pixels are going to decrease, right? Then yes, after performing, this is nothing but the, sorry, this is not the opening operation, actually this is erosion operation. This is nothing but actually a original opening operation, right? So in this case, after performing opening erosion tends to reduce the white pixels and increase the black pixels. Okay, after performing this, if I am going to perform the dilation operation, definitely the black pixels are going to reduce and white pixels are going to increase, right? And it is happened over here as well, right? So I hope you can identify the changes over here. The black pixels are more, but once I am going to perform the dilation operation, after performing the erosion operation, I'll be getting more white pixels, right? And then this is nothing but my, now we are going to perform again a reverse operation now. Okay, so this is nothing but my opening operation we have performed over here, and now what we are going to do, we are going to perform yes, it is opening operation, and on that now we are going to perform again a dilation operation. Okay, so this is nothing but my opening operated image AOB finally. Okay, on this image I am going to perform once again a dilation. Okay, so dilation operation, that means now we are going to perform a closing operation. Okay, closing operation means first we need to perform the dilation and then we need to go for erosion. Okay, so after performing this dilation, now over here we are going to perform the erosion operation, and you can check out what is the changes into the your original image, and finally opening followed by closing operation performed on this particular original image. Okay, so I hope this A image is far weaker, or let us say we can say that it is more it is not giving more proper information related to the particular fingerprint. So this opening and closing operation, once we are going to perform on this particular image, that is a fingerprint, it has given a more meaningful image as compared to your original image, right? So now we can go for the comparison with the that different fingerprints, and then we can say that yes, the fingerprint matching operation has been taken place or not. Okay, so like that we are going to use the opening and closing operation on black and white pixels, black and white images only. Remember that we are going to perform the morphological operations only and only for black and white images. Okay, remember that. Fine. So in this lecture we will conclude over here itself, and we'll continue in the next lecture. Okay, thank you.